Welcome to this new video. We are going to use Blender version 4.2. Our 3D scene starts with the default cube, which we are just going to resize. Here is a cube transformed into a large rectangular parallelepiped. Let's apply all the transformations to it. Naming objects is a good practice to keep track of them later. A domain in the Physics tab is what will allow us to calculate animations for smoke, fire, or water. I increased the number of frames in the timeline. I set the same number in the calculation cache. It is a good idea to choose a location for the cache on a fast disk, ideally an SSD. I take this opportunity to correct the typo. We are going to create a new material that will actually be smoke. Let's divide our workspace to have the shader view on the right. This material is not applied to the surface but to the volume, so we need to choose principled volume. We will start with a density of 10 and a white color at 100%. The one on the numeric keypad allows us to reset to a front view. Let's prepare the camera view, and then adjust it relative to the back of the domain. The second object is a plane. We orient it to stand upright on its edge and place it at the back of the domain. It is also an object that needs to be defined in the Physics tab. It is a smoke flow emitter. A velocity on the y-axis of -4 meters per second allows the smoke flow to be directed horizontally from back to front. The bake function on the domain calculates the appearance and animation of the smoke over 500 frames and keeps it all in cache. The resolution divisions parameter of the domain set to 32 allows for a quick calculation. In return, the smoke animation is coarse, but it will be fine for checking its flow in the 3D space. By the way, the smoke rises, and we don't want that. Let's change the gravity to 0 so that it doesn't affect the animation. We recalculate to see the result. This is what we wanted, a horizontal flow. To add turbulence, create an empty object, position it in front of the domain, and orient it. Then in the Physics tab, choose a force field, and the one we are interested in is vortex. We don't want a tornado but something lighter, so a value of 0.01 in strength will do, then add some noise to avoid having something too linear. I like to recalculate to see what it looks like as I make changes. Okay, that's not bad for a start. Let's move on to the rings. There's some work to do. Here is the first ring. Position it in the upper half of the domain, get approximately close to the spot, and then look at the Z value and round it off to set a reference value. Shift+D duplicates the ring and X restricts movement to the X-axis. Same method, find the approximate place and then set the value by rounding it off. This allows you to give the third ring a symmetrical value. The next ring will be moved on the Z-axis first, then on the X-axis. Finally, the last ring is positioned symmetrically relative to the previous one. This is approximately correct according to a model I have in front of me, except for the intersections that don't work. Mr. Pierre de Coubertin drew this symbol of the 5 interlocking continents on paper in 1894 and didn't think someone would want to use it in a 3D environment. Thus, the blue ring goes over the yellow one at the top and under it at the bottom, and it's the same alternately for the other rings. In a 3D environment, we will falsely create the same illusion. Here is the method I used. Duplicate the ring for which we will handle the spots where it goes over neighboring rings. The idea is to keep just a portion of the ring to serve as a cookie cutter to remove the spots where neighboring rings go under it. After creating an arc of a torus, expand it a bit on the y-axis to make an effective cookie cutter. Then, with a y-axis rotation, place it where the ring, in our case the yellow one, goes over its neighbor, the blue one. You can refer to the model I displayed on the right. Once placed, select the ring from which we will remove its crossing, i.e. the blue one. Stay focused. Magic will happen by using the Boolean modifier, then set the mode to difference with the object we just created and apply the modifier to actually change the mesh of the blue ring. Rotate again on the y-axis to position at the next crossing and repeat the same operation. Once done for this ring, you can delete the arc of the torus. It is no longer needed. Move on to the green ring for the same operation. I won't explain everything again. You will have to do this for all the rings. It goes quite fast actually. Here it's interesting, it's not what we expected. If this happens, just change the position of the arc of the torus by rotating it on the y-axis and tinkering until it works. Finish all the rings now that the method is understood. And there you have it. It looks like the interlocking Olympic rings. Let's add some color to all this. Instead of having colored rings, we will make them emit light to illuminate the surrounding space. Color all the rings the same way. I even set the black ring to emit light, but it doesn't work. It stays black and emits nothing. To make it look nicer, we will use the cycles rendering mode instead of EV and reduce the number of samples to stay reasonable. I also disabled the noise for the renders. In the color management section, we will choose Chronos PBR neutral with a high contrast look. Then we will leave the environment completely black. Each ring will also have a physics setting of the type effector. I take the opportunity to correctly name the flow emitter. And recalculate for the domain. Let's look at the result at several points in the animation. I delete the default lamp that was there from the start. It's starting to look like something nice. These are the 2024 Olympics and they are in Paris, so let's write that too. Switch to edit mode to do that. Adjust the size and position inside the domain. This is not the right font. Here is a site where you can download a very similar font. Then just select the downloaded file and the correct font will appear. In the geometry section, extrude with a small value. In the side view, place the different objects at the front of the domain. Switch to camera view and take the opportunity to convert the text into a classic 3D mesh. Like the rings, the text will also be an effector. Work on the material for the text. I won't detail the steps to create this material, but feel free to pause and get inspired by this. Add an area light and position it to illuminate from the left side and above. The idea is to illuminate the black ring which does not shine. Now for the finishing touches. We need to recalculate the domain, but we'll increase the resolution from 32 to 128. This will take much longer. I speed up the video for you. Let's see this first result by navigating the timeline. We can find a moment where the black ring is not invisible. For the finishing touches, we will add some settings with compositing. The glare node set to bloom will add power to our image. Select all objects and apply a shade smooth. Let's prepare the final render, first by increasing the domain resolution again and recalculating it. Lower the smoke density from 20 to 10 if necessary, or even to 5 as I do. Then find the right frame in the timeline and adjust the light to better orient it and increase its power. Significantly increase the number of rendering samples. I will increase the resolution to have a 4K image. Start the render by pressing F12, and here is the final render of our composition, a Paris 2024 logo with the Olympic rings and a cloud of smoke, symbolizing the weather during the opening ceremony. Have fun tweaking the parameters of this simulation to your liking. In the video description, you will find everything I used. Feel free to leave your comments.